Hi, and welcome to the support series videos from Vectra. In this series, engineers will go through some of the common requests we see from customers and how to resolve them. Please be sure to subscribe and check back for new videos in the series.
Hi all, welcome to Vector Support video series. I am Muhammad Pasha from Vector Support team. This is the second video in a series covering Wireshark. In this video, we will look at what Wireshark profiles are, how to save a display filter. We will also look at the benefit of having profiles with a DNS tunneling example. We have a pcap here, so it's a simple DNS query response pcap. So you can see that the host 192.168.1.52 is making a query for google.com, and then we are getting a response back. Now, to understand the profiles, right? So if you look at the bottom corner of the on the right hand side, you would see something called as profile default. Now, within the profile default, if you look at the column names here, right, that are listed as part of the packet list pane, you would see that we've got the packet number, the time, the source IP address field, destination IP address field, protocol length, and information field. Now, we can use the benefit of a profile. So let's see that in action. So what I'll do is so I'm gonna right click here and then go click on new, then create a new profile called DNS profile and click save, right? So once we do that, let me increase the font. Once we do that, right, so we will see a new profile here called as DNS. Now let's make some modification to our column fields so that so that it would allow us to see the benefit of having a different profile. So let me go ahead and click on this icon. I mean, if you see this icon, so it says resize packet list column to fit contents. The reason that I'm doing is some of the content gets hidden here. So when I click on that, so you can see that it gets arranged properly here. Also, I'm going to go ahead and change the layout. Yeah. So now let's say some of the fields that would be of interesting to us as part of the DNS, right? So one is the transaction ID. So I'm going to go ahead and do right click and then apply as column, right? And then you can see the transaction ID field. Uh, I'm also going to go ahead and add the query here. So I'll add this one. So this is nothing but the DNS query name that is being made. Let me apply as a column. So what I would do is add right click on the name, and then what I would say, let's edit the name to DNS query name, right? And what else would we need, right? So let's look at the response itself, right? We would also need the DNS query length, right? So let me add that. Then I'm gonna edit this. So and we can also add a DNS response here as well. So we can go to answers. Yeah, one of the other things that we can add here is the time to live for the DNS. So a DNS record basically, and we add this as well, right? So basically, if you see, so this is the DNS A record because it's an IPv4. I mean, we can have multiple entries. I'm gonna leave this for now. Now, the other thing that we can see within Wireshark, right? So you can see something called as request in one, right? So imagine if you have hundreds of packets. Now I want to identify uh, out of this, right? So between these two packets, we can have other traffic as well captured, right? And if I want to easily narrow down, go back to the packet where the request is being made, to which we are seeing this response, we can just simply click on that, double click on that, and then it will take us back to the request. And similarly, within the request, you'd also see yeah, an hyperlink which says response in packet number 2. Again, we can double click that to go to the response for that particular query. And one other thing that I want to highlight is if you look at the square brackets here, right? So anything within the square brackets is a Wireshark derived field. So this field is not present automatically in the packet itself, in the DNS header itself. But this is something that Wireshark has calculated and added in order to help us with any sort of investigation that we are doing. Now let's see how to save a filter, right? So let's say we have a pcap which has um, traffic for different protocols, right? So within the same pcap, you would see traffic for, let's say, DNS, HTTP, HTTPS. But we want to filter. So as we saw in the first video, we could simply apply a filter something like a DNS to filter for DNS traffic. But it's sometimes hard if you want to remember all of these filters. One quick way that we can do is what we can do is we can simply create a filter as part of the profile DNS here by clicking on the plus icon here on the right hand side top corner. So once we do that, so it will ask for a label, so you can give anything. So I'm going to simply say that it's going to DNS filter, indicating that it's going to filter for DNS traffic, and the filter itself. Now, because I had it populated here, so it automatically picked that particular filter from here, and then I can click OK. So now every time I have to oh, analyze some DNS traffic, I can simply switch to the DNS profile and then click on DNS filter, and that would filter the DNS traffic for us. Now, so so the benefit of having profiles like this is something, right? So we, if I go back to default, right, profile, you would no longer see all those columns that have been identified. And because I already have another profile built for DNS, so I don't need to go through this process that we saw earlier of adding individual columns that we need to analyze DNS traffic. I just need to go ahead and simply transition to that particular profile, which is the DNS profile, and then it would automatically pick from where we left off. Now here I've got another pcap file which I just downloaded basically from internet, where we see DNS tunnel occurring. Now, uh, to begin with, we can simply go to statistics and look at the protocol hierarchy. And if we look at this particular protocol hierarchy, we see that we do see the DNS as well as ARP traffic, right? There's some percentage of ARP traffic. So, so as I scroll through, I definitely see the ARP request and ARP response here, right? Now, let's say, I just need to now analyze. I know that uh, I'm supposed to analyze this DNS traffic, so I'm going to go ahead and switch to the DNS profile. Now, what I can do is I can simply do apply the DNS filter. We no longer see any ARP traffic now, and also as you can see here, so all the traffic, right? So for we see all of those columns that we added. I mean, I've added few more columns from the last time that we saw. So I added something called as the record type, and basically so let's now just look at this particular traffic, right? So I mean, now we don't need to go through the individual contents, right, under the packet bytes, right? So this makes the analysis easier, right? And what I can do is, again, I can click on the resize column here, so it will resize. And so basically now you can see that it has resized some of those columns, right? Now for now, what I'll do is I'll just right click and hide the transaction ID. uh, so because I've resized it, so I have got this actually columns moved to the right. So let me rearrange them. So what I'll do is, let's say I'm gonna hide the time as well, though we need it. So for our and then we know that it's DNS, so I don't need the protocol field, right? And let me rearrange this. And now, so immediately what we can see is some of the I mean, immediately within this traffic, we know that there is DNS tunneling happening, because if you look at um, this, right, so the DNS request, right, the query that is being made, right, and all of these DNS queries are going from that same IP address of 10.02.30. So the very first thing is we see higher volume of DNS traffic or DNS queries being made from the same IP address. And it is also making this query to the same domain, uh, right? So it's the query, the volume of traffic seen to the same domain, which is .pirate.c, is also in higher number. Also, we can further, just by looking at this, right, so we can look at that the DNS query name is being made. I mean, you can see the host name, so you can see multiple host names here going to the same domain, which is also an indication of a possible DNS tunneling happening. And also, if you look at the time to live value here, it says 0. I mean, usually when a genuine DNS query is made, when we receive the response, this time to live would definitely not be 0. And then record type, right? So ideally, when we make a DNS query, so that would be either either it can be a record type of A, which is for IPv4, or quad A, which is for IPv6, or we can also have something like an MX record for mail server, right? And or we can also have something like a pointer record, right? So, or we can call it as what which is in other words known as pointer or reverse DNS record, right? So, but seeing null traffic should also be an indicator that this is something is not right here. And so basically, looking at all of these indicators, so we have a single host making quite a few queries to the same domain with quite a huge volume of host names, right? So different host names for that same domain. And then also, if you look at the DNS query length, right, so as you can see, the length seems to be fishy, because now it's probably you won't have lengths which are as big as this, right? So you can have up to 253 characters, but in an ideal scenario, you would not see something as big as 252 characters. Along with that, if you look at the uh, host name itself, so it ideally it would be something like an English word dictionary or something like that, right? So or followed by a number. It wouldn't be something like this. So yeah, and this is about it for this video. Hope this has been informative. Thank you.